episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor. Welcome, everybody, once again to another episode of the show, bringing you another fascinating guest today and a story. Another wonderful case of someone helping to create a better tomorrow on many different fronts. Today, we have the honor of being joined by Mike Graglia, who is the managing director and co-founder of the SynGAP Research Fund, which is an organization that he set up back in 2018 after his son was diagnosed with this rare neurological disease caused by insufficiency in SynGAP protein, which causes a variety of life-changing diagnoses, including epilepsy, autism, sleep disorders, and forms of intellectual disability. And the mission of the foundation is ultimately to improve the quality of life of SynGAP1 patients through research and development of various treatments, therapies, and different support systems. Previously, Mike worked at the Emerson Collective, the New America Foundation, the Bill and Melinda Gates Foundation, Boston Consulting Group, the World Bank and the International Finance Corporation, and the U.S. Peace Corps, where he spent some time in Africa, creating a charity to fund girls' education. Mike graduated from Gonzaga University with a bachelor's in mathematics. Then he attended Johns Hopkins School of Advanced International Studies and Columbia Business School. A lot to talk about today. But Mike Graglia, thank you for taking time to come on the show.
Thanks for having me, Aaron. It's great to be here.
It's great having you. I'd love to start off by passing you the floor for a little bit, just to talk a little bit about yourself and your son, of course, and a little bit of how this story all started for you a few years ago.
Right. So, as you mentioned, I had a career before my son got sick, and I was happily working at a great job. I was doing finance and planning, budget and planning. I was doing budget and planning at the Emerson Collective, which was an amazing organization. It's Lillian Powell Jobs shop, and just touching wonderful things. And I was like, wow, this is a job I could stick around in. This is pretty great work. But unfortunately, I started that job when my son was 4, and we had just gotten this diagnosis that really took a little time to hit us, and then our responses to this diagnosis, it took time to understand the consequences of that. So basically, the story is, when Tony was 0 to 2, he was a little slow. Whatever, first kid, he'll be okay. He's a boy. He'll grow out of it. Right around 3, he started having some staring spells, and then those turned out to be. And then he had a convulsive seizure, so he fell down, and we realized, okay, he has epilepsy. We live in the Bay Area. I'm fortunate to have some really good care. And I mention that because in my current role, I now see families who don't live next to major medical centers, and it takes them longer to figure out what's going on. But through a series of genetic tests, we had to go through 3 rounds of genetic testing to confirm that Tony actually had this disease. At Tony's 4th birthday, we found out Tony has SynGAP1. And, I'd never heard of SynGAP1. I didn't know about rare disease. I didn't understand what genetic epilepsies were. I knew nothing. But like any parent, you just call everyone you know and you try to figure it out. And my wife and I did a bit of a tour, and we're fortunate to be put in touch with some very senior academics and researchers and clinicians. And we came away with sort of 3 ideas. One of them was, it's a terrible disease, but if you're going to get it, it's a good time to get it, because science is at a point right now where you can actually believe you can go after it. Yep. Second, apparently what people do for rare diseases when there's no treatment and no one knows what to do with you, if you can raise the money, you fund postdocs. You go and find labs that could help, and you give scientists you've never met lots of money, and they hire someone and have them work on it for a couple of years. And this is a thing. I had no idea. So we're like, okay, we'll do that. And the third thing we realized is there really wasn't an organization focused on driving research for this disease. Yep. And we're like, oh, that's a problem, right? So we created one. As you alluded in my introduction, I have a bit of a professional history in professional philanthropy with the Gates Foundation and Emerson. And then back when Peace Corps, I created a small charity to give scholarships to kids in my school. And So I knew how to do this. And I was like, no. There needs to be a 501c3 that is respectable and drives science that we can put funds into and we can use to raise money. So we did that. And we naively thought it was just a function of how much money can we raise? How fast can we make the science happen? And that's naive because it's important, but it's not enough. What we realized then was, the goal is to get a therapy to put into kids. You're going to put a therapy into kids. You got to get past regulators. To get past regulators, you need patient data. And we didn't have a lot of patient data because the patient community was not well organized. And so it was like, okay, how do we do that? So you engage the patient community and you start gathering data into a registry. So we identified a registry part and we built that up. And we went from a small board of my wife and I and one of our advisors, one of my old bosses at the Gates Foundation, to now there's 14 families on the board. Mm-hmm. But at that point, we were no longer just a funding vehicle, right? It's called the SynGAP Research Fund. Our initial vision was we're going to just accelerate science. Sure. At that point, it was a full-blown patient advocacy group. And at the end of 2018, I had spent a year at the Emerson Collective and I was working really hard, an amazing place that does a lot. And therefore, my job, budget and planning, looking over all of it, I was pretty busy. And I was running SRF at night. And it was, my wife and I had a conversation and she was like, look, you need to pick one. She's like, if you're going to, we either need to pay someone to run SRF or you need to do it, but you can't be doing both because you're not sleeping. And, and my wife, fortunately for us, is an investor. And she's like, I can keep us going. You go work, you go do SRF. It's the right thing for our son and our family. Mm-hmm. So that was 3 years ago. And I left my work. No, that was right before pandemic. Sorry, the story is blurring for me. So Tony is 7.5. Mm-hmm. Tony was 4 when he was diagnosed. We created SRF. I continued to run SRF in my spare time for about 2 years. And then a year and a half ago, just before the pandemic, there's a time point none of us can forget, right? Sure. Just before pandemic, my wife and I had this conversation in February. She said, this is crazy. I can't do another year like the year we just had. So she said, pick one. And I said, all right, I'm gonna run SRF full time as a volunteer, which frankly was a little weird to do, to walk away from, decades of a career and such an incredible professional opportunity. But it was the right thing to do for my son. And so I did it. And then the pandemic happened, right? Mm-hmm. Bananas. But the thing about rare disease is all of our families are taking care of a very sick child.
Yep.
None of their friends or frankly extended family understand their lives. And our kids don't sleep. So most of our families are pretty isolated and pretty much glued to their mobile phone all the time, right? So for rare disease families, very little changed, right, when pandemic happened. And I had just jumped into that bubble with both feet. So essentially, the past year and a half, I have just been working full-time on SRF, expanding our work and engaging our families. And I now sort of split my time 3 ways between looking at the science, so managing our existing grants, finding new grants to give, raising the funds, managing the patient data side of it, so recruiting people into our registry and making sure that data is being used by others. And then third and finally, just supporting families. We now have a newly diagnosed family pretty much every week. And I don't do this alone. I'm one of the only people who does it full time as a volunteer, but there's dozens of families who volunteer. So in partnership with all of them, we're talking to another newly diagnosed family every week. It's crazy right now.
It's, as you were saying at the beginning, you hadn't heard, I haven't heard about SynGAP until I met you. I've done some shows in the past in rare diseases. And, the interesting thing in this case, as you point out on the website, the incidence somewhere 1 in 4 in 10,000 people, you do the numbers. There's a lot of people there. It still puts you in the rare disease class, but it's a big rare disease, let's say, compared to some of the things we touched on in the past. And you make the point that it comprises, if you look at things like Fragile X and Engelman's and Rett's, many more intellectual disabilities than all those combined. That being said, it's a rare disease, and you have to deal with all the proclivities and so forth of having to, as you said, the data and trying to do research and so forth for rare disease. Talk just a little bit, and we'll get into some of the things in terms of treatment and research and repositioning that you're doing. Just say a few words more about, because you mentioned Bill and Melinda Gates Foundation, which obviously deals with malaria and HIV and
Right.
tuberculosis and things like that. What are some of the learnings you brought from that experience? Understanding you were in finance, but nonetheless, you were around some amazing minds working on those big diseases. What did you learn working at some of these foundations, and how are you applying some of what you saw there to this rare disease situation, which we have, these 6,000 to 8,000 other rare diseases out there?
Yeah, it's a really good question. And it's actually a question I haven't gotten before. So there's a number of levels, right? So SynGAP Research Fund, as you can see on the logo behind me, underneath our logo, it says collaboration, transparency, urgency.
Yep.
And for me, that was top. When we created the organization, we created the logo. Collaboration is essential, right? Because the amount of work before us is staggering, and we can't do it alone. So we're going to work with anyone who wants to work together. Urgency is obvious. My son is sick. He's getting older. He's getting bigger. His brain is being built badly. The sooner we do something, the better. But transparency, I think, is really important. When you deal with anything from the United Way to a small little rare disease foundation to the Gates Foundation or the Emerson Collective, you need, I think, as a donor or a partner to any of those entities, you need to ask the question, what's going on? Where does the money go? If you're dealing with a public charity. Now, Emerson and the Bill and Melinda Gates Foundation are different because you got one funder in the case of Emerson, you have two funders in the case of the Bill and Melinda Gates Foundation, you have Bill and Melinda, and then you have Warren Buffett. But I have come to believe giving funds to charities. So at the Gates Foundation, what I did is I touched a lot of different grants, and the foundation, the Gates Foundation, we gave money to a lot of partners, and we really double clicked on their financials before we gave them money for a variety of reasons, right? Are we going to tip them into a private foundation? Are they sustainable? There's this notion of absorptive capacity at that level, where I want to give you this much money to do this much work. Can you actually take that much money? Like, it's a weird question until you get to that level. Like, can you actually do this? But I'm going to come back to that. So I really came out of my years in philanthropy believing firmly that transparency is critical. You cannot ask people to give you money if they don't know where the money's going. So in the case of SRF, what that means is that we have a lot of information on our website about our grants, like status, how much dispersed, whatever. And then the other thing at Gates that was a perpetual nightmare was the overhead conversation, right? You're giving an organization a bunch of money. Well, we need money to keep the lights on, rent, senior executives, blah, blah, blah. What's the right number? Nobody comes out of that meeting happy. It's never a good meeting, right? No one's like, oh yeah, we found the right number. The organization always feels like it should be higher. The donor always feels like it should be lower. It's mentally exhausting. And my wife and I are so committed to to the SynGAP Research Fund that we said, no, we will cover all overheads. If there's a cost that isn't money going to a scientist, we will pay for it, right? The rent, the room I'm sitting in right now, the phone I use, everything, we will pay for it. The accountants, the lawyers, we will pay for it. Because to hold ourselves accountable in a sense, right?
Sure.
So if we're spending money, it's our money run through public charity. And what we're saying to donors is what I can say to donors now is 100% of the funds you give will go directly to whatever effort we're doing. And all those efforts are clearly described on the website. So the biggest takeaway of all my years in professional philanthropy is transparency is critical. But I think your question was more scientific, right? And I think what's interesting there is if you look at the way we did things at Gates, because Gates had a very specific belief, a strategy focused philanthropy, right? Like, this is the world we want to see. Here's how we're going to get there. We're going to give grants that make that vision happen. Whereas I think I have to be careful what I say about Emerson, but I think it's public and well understood that the model of philanthropy there is more finding places that are doing great work, giving them unrestricted funds most of the time, and letting them support it, right? So two very different institutions. And there's just different philosophies behind them, and it's very generous people's money, and they can do whatever they want with their money. But what I took away from Gates is that this notion of strategy-focused philanthropy actually is a thing, and you can do it. And that's basically what SRF is. We live in a world where there isn't a therapy for my son and the hundreds of other children like him. And we want there to be one, right? So what do we do to the world? And then the obvious, the low-hanging fruit is go find people working on the disease, give them more money to go faster. That's what we did. Mm-hmm. Looking back, I don't think that was the best use of funds. I think now we're being much smarter with funds, because now what we're saying is, okay, maybe it's those labs who will find a cure. Maybe it's a biotech I haven't heard of who will find a cure. Maybe it's a lab I haven't met. I don't care who finds a therapy for my son.
Sure.
But when they get to the finish line, I want them, things don't fall apart in the lab. they do, but things don't always fall apart in the lab. Where things fall apart when you're talking about a therapy is the regulators and the clinical trials and all of that. So now what SRF is raising funds for and spending a lot of money on is making sure that essentially that trial is, my dream is to be able to say to any biotech who one day, and I get these calls already at different stages, we think we have something for SynGAP. What I want to be able to hand them is, great, here is a template for your clinical trial design. Here's the biomarkers we've identified. Here, the fluid biomarkers, the EEG biomarkers, et cetera. Here's what we think you should go to the FDA and talk about. Insert your drug name here. Let's go do this. Because then I'm not playing poker anymore, right? I'm not betting on this or that or that. Instead, I'm saying, I'm just building a bridge over a nasty river that I know everyone's going to have to get past, And that is this idea of strategic philanthropy and this idea of partnering with scientists. Yeah. And also, I think one of the biggest things I learned at Gates, because I did this before Gates, I was at BCG, right. And Gates hired BCG to do a lot of work, and I was pulled in for this incredible assignment where I got to go into a bunch of labs and talk to scientists. And then my job was to go into that, and I was a math major, right? I mean, anything with more than 3 syllables, I can't spell it. And I'm walking into these amazing labs, these amazing scientists, and my job was to look at a portfolio of 9 grants and whittle it down to 3 grants and say, here's the 3 that you should continue to support, and here's the business plan for it. And I said to Gates when I got staffed, I was like, are you crazy? Like, I don't even understand anything. They're like, no, it's great. Like, we don't need someone who understands the science. You're talking to some of the best scientists on earth. What we need someone to do is to figure out if this is commercially viable and the path to the future. And we really need a business brain on this. And I was like, oh, okay, that I can do. And it was amazing work. And as a result of that work, someone at Gates called me and said, we want you to come and work here. And that's why I went over. But what I learned from that is that I don't need a PhD in whatever people have PhDs in to sit with a scientist and say, explain to me how this is going to work. Like, and every scientist has a great speech about how just throwing money at basic science is worth it because we improve humanity, blah, blah, blah. Great. Wonderful. Call the NIH. My son is sick. My focus, I'm here because I want a therapy for my son so that when I die, I don't have to worry about who's going to take care of him, right? Our kid, the thing about SynGAP, we should talk more about SynGAP 1 generally, but the thing about SynGAP 1 is our kids, this is not a degenerative disease. Our kids will not die of this disease, but our kids have seizures, sleep disorders, behaviors, other challenges. That means someone has to have eyes on them 24 hours a day. Mm-hmm. And you have to really have smart people and people who know this disease managing their meds, because if their meds get out of whack, you have a variety of serious problems. So every SynGAP parent is frankly terrified of dying because we're like, nobody knows my kid like I knew. My kid's never going to leave the house. Oh my God. It's everyone's nightmare. And so for me, the clock is ticking in a very real way. Like, how many decades do I have left? When can we get something in Tony's head? And so when I'm talking to scientists, I'm not interested in the basic science. For the first year, I was dazzled by their brilliance. And now I'm like, it's great. I'm glad you're brilliant. Tell me about how this is going to get me closer to a therapy, right? That is the conversation I have nonstop. And so what I learned from my time at BCG and at Gates is that there is space to partner with scientists, right? You can have this business brain and this acumen of, okay, what's the critical path? How is this going to make things better? And then, and I sort of got over my imposter syndrome, because back then when I was a little BCGer walking in these labs, I was like, why am I here? Now I'm like, no, I know exactly why I'm here. And I believe that I have value to add because we both want the same thing. We want your science to change human lives. Mm-hmm. So let's do that together. Yeah. And I think that was the biggest learning from Gates. And then overall, this fundamental belief in transparency, and that you have to, as a public charity, you have to earn people's trust and respect by telling them exactly what you're doing and being able to be proud of that.
Outstanding. As I was looking through the website and sort of you do this extremely comprehensive overview in terms of the existing therapies for sort of management of the various parts of the SynGAP syndrome, and then another part is in really the comprehensive sort of gene therapies and the CRISPR and the oligonucleotides. Yeah. In between, though, is an area that we've actually touched on a few times on the show, and I'd love to go into it a bit with you, because it's sort of in between the waiting for 30 years to get something and what we may may have a lot sooner, and that's this topic of repurposing, where you talk about one, I have no idea about this, but this connection between potentially statins and some of the non-cholesterol control mechanisms, and then also, you go into that repurposing, investigating the wealth of compounds and maybe approved drugs that are already out there in different types of models and so forth are critical and core to SynGAP's mission. Talk a little bit about the theme of repurposing. Are you seeing exciting things, aside from the statins, which is very interesting on its own right, but what are you seeing in terms of sort of this repurposing dynamic with regard to SynGAP research?
We're seeing it across rare disease, right? And it's a problem I've struggled with since day one. So we jumped in and we funded some ASO, antisense oligonucleotide work, and some other animal model basic stuff. And I said, well, what about repurposing? Like, in the short run, what can we do? And I was told by one scientist who has a large grant from the NIH, don't worry, we're doing a massive screen. It's really fancy. We're using mouse brains and blah, blah, blah. I was like, wonderful. Someone's already doing it. I'm happy. And then like a year and a half later, I called him up. I was like, what's going on, man? Like, when are you going to have information? Well, I have some early readouts, but we have some positive, we have no positive hits yet. We have some negative hits. And I said, what's a negative hit, right? So a positive hit, because again, SynGAP really fast. We have 2 copies of every gene, you and I, one from mom, one from dad. My son, one of those copies has a typo, and as a result, it doesn't work. So as a result, he has 50% of the necessary amount of protein. That's this kind of disease in a nutshell, right? The goal is we can treat all the symptoms. We can treat the epilepsy and the behavior and the sleep and the motor issues and we can treat a fraction of all of those with different drugs. A, it's unsatisfactory because we're going to get all those side effects. B, we're going to destroy his liver before he's pick a number, right? So really what we need to do is we need to go to the root cause and upregulate, make more of that SynGAP. And antisense oligonucleotides and these genetic therapies that we're talking about really go into the brain and work on the genes and either make a gene make more SynGAP or actually fix the type, whatever. That's a whole level of, I call it the sci-fi realm. And some of that sci-fi is 2 and 3 years away, and some of that sci-fi is 10, 15 years away. It's coming fast. But in the meantime, if there is a drug right now that we can just pop in our mouth, like Tylenol or whatever, and it, by some magic, helps the body make more SynGAP, we need to figure that out. And so, that's the idea of repurposing. Can we find a drug that we already have in hand that is already made and on the shelf and figure out that helps our kids? So I talked to this researcher. He said, we have no positive hits. We have a couple negative hits. I said, well, what's a negative hit? He said, a negative hit is this drug goes in and it makes the SynGAP go down. And I was like, dude, that's important. Like, our kids are sick because they don't have enough SynGAP. And you're telling me you found drugs that are currently out and about that can make SynGAP go down. So we should tell people that so that they don't give those drugs to our kids. He was like, no. This is science. I'm going to wait till I have all my data and then I'm going to publish everything together, which I was not thrilled about. I said, okay, when are you going to be done? He's like, I'm working on it. A year ago, the pandemic happens. He calls me up. He's so happy. He's like, hey, I just got an extension from the NIH. I have 5 more years to do this project. He was so proud of himself. I was like, are you 5 more years? And so drug repurposing went from the back burner for me to, okay, this is not an acceptable time frame. Like, is there anything else we can do? And when you're a small rare disease group and you're trying to figure out drug repurposing, then what you start looking at is all kinds of crazy, right? So people they make flies, they do yeast models, they do fish models, they do all these things where you basically make a bunch of animal models with the disease. So you genetically engineer the animal, so the animal has the disease, assuming that you can find some kind of parallel version of the gene in the animal, right? So for instance, we have SynGAP in our brains. If you go back in the evolutionary tree, you get to zebrafish, which are great because you can make a lot of them really fast. They have 2 copies of SynGAP. So people have had to figure out which one would you take down to actually have a fish that has seizures. And a fish with seizures is great because you can just figure that out with a camera. And then if they're swimming in a pool and you drop the drug in the pool, the fish start swimming normally. You're like, something happened. It's pretty cool. But it's really complicated and really expensive. I mean, think of labs full of fish bowls and fish and lots of different drugs. It's a pain. And all of the proposals I was getting for fish and flies and worms and was hundreds of thousands of dollars and then maybes in some amount of time that would result in a lot more work. And they were always sort of unsatisfying. And I'm not the kind to just throw donor money at the first idea I see. I was like, I need something that makes more sense. And then I was so thrilled when RareBase came along. So RareBase, we just announced this grant a couple months ago. Rarebase called me up with an idea that made sense. And it made sense for two reasons. A, the science is elegant, and B, there was some financial innovation. So back to your question about Gates, one of the, I won't bore you with the details. One of the coolest things I did before I left Gates was put together an entire fund where we put in a lot of money, and that was leveraged through a regional development bank to catalyze a lot more money. And it was a really smart use of philanthropic funds. And with Rarebase, it's basically the same story, right? They called us and they said, instead of making a fish or a cell or a worm or whatever, it's a SynGAP mutant, we have a way to take a healthy cell and run the test on the healthy cell and then measure the SynGAP level in the healthy cell. And that will help us know which drugs to go after. And because we're working with healthy cells, we don't have to do just SynGAP. We could do SynGAP and STXBP1 and FOXG1 and pick a few other genes. So instead of, and this, when I say the science is elegant, the way that works is they take the healthy cells, they put a little drug in, and then they measure with some transcriptomics the level of gene expression in that cell, right? Because really, because the question of does this drug help a mutated SynGAP cell is almost a second order question. The first order question is, does this drug in a cell make SynGAP go up?
Right.
And if we can answer that much faster and cheaper, let's answer that first, go from 5,000 drugs to 20 drugs, and then start double clicking on the 20. Mm-hmm. So what Rarebase came to us is they said, we're doing this transcriptomics, it's cutting edge. And I said, yeah, I've heard about it. And I have a friend who's working on it. And their proposal is coming in at $1 million. So for one gene to do some transcriptomic work with one of the best facilities in the US, they were getting a proposal around $1 million. That's a lot of money. And Rarebase said to us, what we're proposing right now is a different model where it's depending on the size of the organization and whatever, it's 100 or 150,000. You can come in, and if you and some partners come in at about $150,000 and some smaller groups come in at about $50,000, we're going to do this screen, and then we're going to be able to look at a lot of genes at once. And for me, that went from being kind of pricey, need to prioritize, to this is a no-brainer, right? So what the good people at Rarebase, and we checked them out, we've talked to them forever. Ono and Omid and Haley and all these, Lindsay and all these really good people there are well known in the rare disease space. And then of course we sicked our SABs on them, and a couple members of my SAB were in those meetings, and we went through the science, and essentially the takeaway was what they're trying to do is ambitious, but it's smart. And if they get somewhere, you're going to have early reads on small molecules that could help your kids early next year. At that point, I was like, all day long. One of our dads went on to do a fundraiser and basically funded the first tranche, which was amazing. So that's a separate story. Essentially, small molecule repurposing is something everyone with a rare disease should think about. Mm-hmm. And one of the reasons we should think about it is a lot of these molecules are already, been patented, off patent. Industry's not looking to make a ton of money off them. And so it's really on us to invest in the testing. And what Rarebase has done is they've brought, instead of us getting the leftovers as a small little rare disease groups, here's some approaches that may or may not work. Mm-hmm. We're going with some cutting edge science to really get a quick read on what might be helpful. And I'm really excited about that particular grant. So, and then I can go back to my families and say with a straight face, we're doing everything we can. Looking at small molecules, looking at genetic therapies, looking at next generation genetic therapies. Like, we are pushing on everything for our kids.
And, speaking of pushing, I mean, as I mentioned on the website, and I encourage everyone watching and listening to go check out the SynGAP treatment part of the website, and you really go into sort of the bleeding edge. And one of the investigators that you're funding is actually right down the street here, Dr. Elizabeth Heller, working in another really hot area, not specifically with the genes, but with the epigenetics, which is a topic that we is very hot nowadays all throughout biotech. Where we have these genes, it might be really tough to do the gene therapies and the CRISPRing of people nowadays, but the non-genetic components of how genes are expressed or not expressed is really hot and sexy. What is Dr. Heller up to? I know you obviously talk about the details of the grant, but this also seems like a very not a quick win, but quicker than some of the more bleeding edge CRISPRing and gene therapies and so forth. Can you tell us what's going on there?
Yeah, happy to. And there's a few great stories there. So the first great story is, Epigenetics is the study of what's happening within the genes, but outside of the gene of interest, right?
Yep.
So, and then we have another incredible scientist, Anna Munyarance, who's just a force in the space of neurological rare disease.
Mm-hmm.
And Anna says it best. She says, we're looking for the boss of the gene, right?
Yep.
SynGAP is really complicated. And there's people are still understanding everything it does. But if there is another gene that can tell SynGAP what to do, and we can get that gene to just tell SynGAP to work harder,
mm-hmm.
we can make more SynGAP. So where's the boss of the gene? And after having thought about epigenetics for years, when Anna Munyarance said that in one of our webinars just a few months ago, I was like, oh my God, that's beautiful. And so that's what epigenetics is, right? It's how do these genes manage each other? These things, nature and biology and life is fascinating when you understand, well, this gene does this, and then there's a pathway, and that gene does that, and that gene does that, blah, blah, blah. And you take this gene out and everything falls apart because now, the gene that dealt with it is out of balance and all the dominoes start falling, right?
Sure.
So epigenetics is understanding the natural interplay of all these different genes. What's the boss of SynGAP? What is upstream of it? What's downstream of it? What are the genes that it interacts with and that manage and regulate it? And we didn't know that. And so one of our research partners called me up one day and said, hey, we don't know anything about the epigenetics of SynGAP. I was like, oh. They're like, and you should fund someone to just basically do a lot of studies to really understand that. And I was like, great, okay. Where do I find an epigeneticist? And then they were like, well, turns out there's this woman named Elizabeth Heller, and she's really good. And I was like, made a note to myself, check out if Elizabeth Heller is really good. It turns out she's amazing. Like you don't have, you Google, like her resume is white hot. She's gone to some of the best institutions. And I remember I was doing diligence on her and I came across one letter of recommendation that for some reason was available online. And it was like a very senior person at one of these prestigious places she'd been to in New York. And it was like, and it literally said, if you do not accept her, you are an idiot. Like she is as good as it gets. I was like, oh, okay, Liz Heller's really good. And they're like, but what's better than that is she has a niece who's affected by SynGAP1.
Yep.
And that is, it's unfortunate for Ruby, for the little girl. But it's great because every scientist out there who's got a lab has got to hustle, right? They got to bring in different funds. They got to keep a lot of people happy. They're making trade-offs on their time. And when you give a grant to someone, you're always trusting that those funds are going to be used 80, 90, 100% for your work, as opposed to 20, 30, 40% for your work, because they can make trade-offs and frankly, there's no way to know, right? Yeah. So you really got to trust people you're giving these large amounts of money to. But when I'm dealing with somebody who is brilliant, like Liz Heller, who's at an incredibly prestigious institution like UPenn,
yep.
and who is related to a family member, it just becomes a no-brainer. Mm-hmm. I'm like, well, of course she's going to do the work. Of course she cares. Of course she gets it. So that was a gift. And then the third gift there, and this is where the story gets even better. We had a family who was also supporting other work in SynGAP1 at UPenn.
Okay.
And I when they were doing it directly, families do different things, different reasons. It's a great family doing great work. And I knew about this, but it was sort of quiet. And then when I got this proposal to support Dr. Heller, I said, I'm not going to jump in. I'm not going to get into this UPenn thing where I'm not 100% briefed. So I called the family up. I said, can you talk to me about what you're doing? Because I don't want to create conflict. I don't want to double pay for something. I don't want. And it turned out they were funding another incredible researcher with his own story. This gentleman named Dr. Ben Prosser. And Ben is a cardiology researcher, just to be clear, because we're talking about the brain. He's a cardiology researcher. But unfortunately, Ben's daughter has a similar disease called STXBP1. And STXBP1, similar disease, right? Haploinsufficiency, one good copy, one bad copy, epilepsy, behaviors, motor issues. It's a tough disease. And he basically said to his management at Penn, hey, I got to work on this disease. Like the science is there. I understand the basics of the science. I got to work on my daughter's disease. At the same time, there's a SynGAP family being like, hey, UPenn, we need you to work on SynGAP1. And somebody connected the dots. And they were like, hey, would you guys support this and let him do both the genes? And it's a wonderful partnership. So when we got the call to do the Liz Heller work, I got on the phone with Dr. Prosser and I said, do you know Liz Heller? He said, no. I said, you guys should probably meet, because we're about to fund her to work on. And now it's this beautiful partnership where you have Liz Heller, who's a brilliant epigeneticist, SynGAP, and Ben Prosser, brilliant scientist who is now basically doing, hearts Monday through Wednesday and brains Thursday through Friday. SynGAP, STXBP1 dad, working together on ASOs, which are which are like the first wave of sort of genetic therapies under the leadership of, this is the beauty of UPenn, there's so many geniuses walking around, under the leadership of this professor named Beverly Davidson, who's got a history of successfully developing therapies. So you bring together this amazing constellation of researchers working at Penn, and I love it. I'm actually, we have a gala tomorrow in Jersey, and Dr. Prosser is speaking. So I'm really excited about what might come out of that. And it's never good news when a kid gets diagnosed with one of these diseases, but the fact that these scientists are in a position to work on it directly is really thrilling. And whoever wrote that thing about Liz Heller's brilliant was right. I mean, if anyone's curious, they should go to our website. They should watch her webinar. She's an eloquent speaker. And hopefully what she's going to do is she's going to come back to us and say, these are other genes you can target. These are other ways to attack SynGAP1 based on her robust analysis that we're funding a postdoc to do right now.
Mm-hmm. You know, I noticed the gala coming up, and I see like you're out on the West Coast. I'm sitting here in Philly right now. SynGAP has a UK component associated. I mean, you're really sort of international now with the whole program. It seems like you're on the go quite a bit. What's coming up? Other things we should be looking out for? It seems like you're going 24 hours a day here with this. But what's coming up in the coming weeks, months? What should we be looking out for in terms of other SynGAP Research Fund initiatives?
It's a great question. So yeah, the gala is obviously a fundraiser, right? We're always raising funds, and it's also a chance for families to connect. I think one of the things I'm always saying to families is, what's your zip code? Do you realize there's, 3 other families within 50, 100 miles of you, and you guys really need to connect? And they're always like, I want to talk to you about seizures and medications and whatever. I'm like, no, you don't understand. If there is this disease is very, very rare, right?
Mm-hmm.
The data suggests there's thousands of undiagnosed kids, but in the US, there's 250 diagnosed kids. Like in the world, there's 883 diagnosed kids as of October 1st, right? Like if there is another family who's diagnosed near you, you have to meet them. You have to connect, because there's just so much that we can get from each other intellectually and emotionally and spiritually, whatever words you want to use. Like, you have to meet these other people who are on this journey with you. And so one of the reasons I'm thrilled about the gala is there's gonna be like 15 different families. And some of them, a few of them, I'm sure, have never met another SynGAP parent in the flesh, right? Because keep in mind, 250 in the US, 100 of those have been diagnosed under pandemic. Yeah. It's crazy if you think about it. So the galas, all these events are exciting because families will meet. So we're doing that. On December 3rd, we're hosting a roundtable, which historically has been in person. So there's a major annual meeting called AES at it's called the American Epilepsy Society, and they have an annual meeting, and it's like summer camp for neurologists, right? They all go, they all hang out. And the idea is, if you have a side, you host a breakfast on the side and you invite people to come, and you have some speakers, you can educate neurologists who, have a terrible job, right? They walk into a room with a sick kid and they got to figure out what's going on. And we want them to not only find our patients, but then get them tested and figure out it's SynGAP1. So the least we can do is just let them know about the cutting edge science and keep them up to date by hosting a thing at AES. So we did that 2 years ago successfully in person. Last year we did it online. This year it's going to be both. I'm assuming AES will end up going virtual. But what's cool about this year's event on December 3rd is that we're doing it in partnership with 2 other diseases, STXBP1 and SHANK3. Because what you're seeing is the number of genetic diseases, genetic epilepsies, goes up every single day. Every single day, just, ticks up. And it's super important to realize the burden that's on neurologists. And I think in the old days, it made sense. 2 years ago, it kind of made sense for us to have a SynGAP roundtable. We are one of the emerging genetic epilepsies. But now we found other like-minded groups, and we're like, no, we should just host something together, because these doctors are looking at lists of genes, and these researchers are dealing with lists of genes to go after. And they're starting to go after some of our genes in combination. See Ben Prosser working on STXBP1 and SynGAP1, not just because there's 2 family connections there, but because the way you attack those 2 haploinsufficiencies is the same. You find something you can target with an ASO and you go after it, right? So there's this collaborative event on December 3rd with 2 other really exceptional rare disease groups. And then in the new year, on April 30th, we're going to do Sprint for SynGAP, which will be one of your regular 5K fun run type things.
Mm-hmm.
And there's a few other galas being planned. It's a real burden for people to be away from their kids.
Sure.
Our kids require around the clock care, et cetera, et cetera. So instead of doing large, long national events, where I'm heading with SRF is, we're going to do like some kind of gala in Atlanta, something in Jersey, or something in California next year, and hopefully something soon near you, because we have such a critical mass at UPenn, and just start to have little regional events where people can connect and get together. But the big ones are December 3rd, the roundtable, April 30th next year, the Sprint for SynGAP, and then stay tuned for more.
Awesome. Mike, I can't, obviously we talked about your son, Tony. We talked about you. I can't obviously let you go yet without talking about your wife, Ashley, who is an integral part of this. This is a family affair. She's a major private equity sort of mergers and acquisitions person. Talk a little bit about Ashley too, if you would.
Yeah, she's amazing. I mean, I just like everyone who's happily married, I just got lucky and beautiful woman walked into a room. I fell in love, and I had no idea what I was getting into. She was just a really pretty, kind, smart girl, and I couldn't believe my luck. And I didn't understand the career path she was on when we got married. It's not like she was hiding it from me. I just didn't understand this world that she was in. And it turns out she's an exceptionally talented investor and works for the Carlyle Group. And she works a lot. And that doesn't stop her from, at the end of the day, when we're just, catching up, going over the punch list with SRF, like, what about this? What about this? Tell me about these people. Like, she doesn't have the time to be in the weeds like I am and really do the day to day, but she's tracking in that incredible mind of hers. She's paying attention to all of it. And, she helps raise funds, of course. She's able to reach out to her network and mobilize donations, which is helpful. But she and I are motivated by the same thing, which is we love our son, and we're going to do everything we can in this life to make sure that his future is as bright as possible, and he's in the best shape possible when we're gone. And so and the way we do that is different, right? I have the luxury, because of her work, of doing this full time and serving our community and engaging with our families. And she has the luxury of being in private equity. And so she's just in there doing what she's good at and helping us fund SynGAP research. And, I personally feel like she's one of the greatest blessings in my life, but I think our whole community, I think a lot of parents would smile and nod when I say this, really feel lucky that we've got Ashley Evans, because she's a force. And to leave aside her professional credentials and her resume, I can look all this stuff up. She's just a very kind person. I think, if you think about funding scientists, I mentioned before, you got to really trust them. You got to really like them. Sure. And one of the things I learned at Gates, and I've relearned it doing this work, is there's a lot of really smart people out there. But if someone can't explain what they're doing and isn't sort of inherently kind, they're naturally not that smart. They're smart, but they're not really. The people who are really sharp are sharp enough to be kind and don't hold over you how brilliant they are. So I'm talking a little bit about the scientists there, but Ashley is one of those. She is so sharp that she's kind and thoughtful and just a good human being. And she's absolutely, if you were lucky, Ira, you'd be interviewing her right now. It's hard to get a hold of her. I have to make appointments, but she's part of the magic of SRF, and we as a community are really lucky to have her, and Tony is very lucky to have her as his mom.
You seem to make an awesome team. So that's Mike, any other things related either to the fund, new initiatives, and anything else you're doing that you want to mention while I have you? I'll give you the floor on the way out.
That's kind of you. Thanks. I guess I'd say two things. Like, one of them is there's 250 families in the US, and they're taking care of very sick kids. There's very few families, frankly, who have the luxury of being I'm just going to work on this full time, because people got to pay bills and put food on the table.
Yep.
So the way that we're really going to make progress is when aunts and uncles and close friends and people who are blessed to have healthy kids and not, and be able to sleep 8 hours a night, unlike those of us taking care of SynGAPians, raise their hand and say, I want to help, right? So I think people just caring and saying, how can I help, is a huge thing. So it's an open invitation to anyone listening. If you like what you've heard and you want to be involved, let me know, because when people care and reach out, that's what makes a difference. And the other thing, I have to make a PSA for genetic testing, because a lot of people don't understand genetic testing or how critical it is. And I want to just say a few things. The first is genetic doesn't mean inherited, right? So Tony has a disease because at the point of conception, when the genetic machinery was copying mom and dad's DNA, there was one typo. We all have typos. Most of them happen in places that don't matter. But if you have a typo on a really important gene, you have a problem. And so genetic testing, the only way to find out if you have a typo is to do genetic testing. And the reason genetic testing matters is all those therapies that we're spending years and hundreds of thousands of dollars in supporting will only work if on a certain gene. Like, that specificity is key. But the only patients who will get those are the ones who've been tested and know they have a typo on that gene. So why am I saying this to the general public? Because if you know a child with autism or epilepsy, frankly, if you know anyone with autism or epilepsy, have you had genetic testing is an important question, right? And if they're a kid, insurance can and should pay for that. If they're an adult, insurance should pay for that, but they won't. And then there's private pay options and other avenues you should pursue. Example, we have a patient who's 65 in a home who the movie is called Karen, C-A-R-E-A-N. If you Google C-A-R-E-N, Karen, in SynGAP 1, you will find this movie. We made a movie about her, 15 minutes long.
Cool.
Doctor was looking for a disease, was looking for something totally different, did genetic testing on her a year ago and found this 65-year-old patient. There's a whole story there. I won't go into it. But if you have somebody with epilepsy and you do whole exome sequencing, 40% of the time, you're going to figure out what gene is behind that. And 10 years ago, that was interesting, but trivia, right? Okay, we know what's causing it. There's nothing we do about that. Today, and in the years to come, genetic therapies are going to come fast and furious. And if you know someone with autism or epilepsy or ID, you should say to the parents, consider genetic testing. And if they say, oh, there's nothing wrong with my family. No, it's not that kind of genetic. It's not inherited. No. It's just a thing. And if they say, oh, we can't afford it, be like, fight for it. Fight for insurance, go to state aid, go to ask the hospital to help you. But kids, there's a lot of kids out there who aren't diagnosed because people haven't figured out that genetic testing can be life-changing, both medically, in terms of you will find therapies, and emotionally, because you remember, before we were diagnosed, our kid was a little bit weird, a little bit epileptic, a little bit behavioral, didn't sleep much. No one was quite sure. Every doctor had a different opinion, random drugs being thrown at him. And people live through this. We did it till we were 4. I just had a newly diagnosed family. Daughter's 11. 11 years of not knowing. Karen, 64 years, right? Until friends and family and clinicians say, have you thought about genetic testing, and really advocate for genetic testing? There's a lot of families out there on this horrible diagnostic odyssey. So maybe it'll be a SynGAPian, maybe it'll be an STX, or maybe it'll be something else. I encourage everybody with a kid who is struggling with those things, autism, epilepsy, intellectual disability, to really pursue doggedly genetic testing. And if your doctor says no, go get another doctor. You know, like this, we all deserve to know this in this day and age.
That's an excellent point. Really excellent points. Mike, it's an amazing story. Clearly, you're on the right path here, and you've put together the right structure, the right people. And we'll put the link to the SynGAP Research Fund in the bio to the show, and I encourage everybody to check out really a very comprehensive team that you have, and really just wishing you, Tony, Ashley, the best with and of course the whole SynGAP team, the best with all these programs, moving them forward. I know you'll be successful. For everybody that is going to be listening to this particular episode on our podcast networks or watching on the YouTube channel, you've been listening to Mike Graglia, Managing Director and co-founder of the SynGAP Research Fund. Mike, I want to take time Thank you for taking time out of your schedule to come talk to us for a little while and educate us on this topic. Thanks for everything you're doing there. And as we like to say on our show, thanks for helping to create a better tomorrow for all these SynGAPians and everyone else and all their families. A very inspirational story.
Thanks, Sarah. Appreciate having me.